Look around. Look at this rocket, for example, or the phone I'm using to record this video, or the house I'm in right now. What all these things have in common? They all could have used or did use CAD, or computer-aided design. Hello, my name is Nathan Aquilio, and I'm a second-year mechanical engineering technology student at RIT. I'm both certified in SolidWorks and Fusion 360 and have held jobs in both fields. Today, I'd like to discuss with you guys what CAD actually is. CAD, or computer-aided design, is simply just a design software, but really is it? First, I'll go through the history of CAD. Then I'll discuss the design aspects. After that, I'll talk about the visualization and simulation. Next, then I'll discuss manufacture, and finally, we'll finish off with the future. Let's start off with the history. It all began with a computer scientist named Dr. Patrick Henry. He created the first numeric control system called Pronto in 1957. In 1971, he called his new system Atom, or the Automized Drafting and Manufacturing System. In 1982, AutoCAD created Autodesk. Autodesk created AutoCAD. In 1995, SolidWorks was made to give a better user interface to the users. My personal favorite. And don't forget about in 2013, where Autodesk first became the first manufacturer to make a cloud-based CAD software. I don't want to bore you with the history, but I think CAD is a more recent technology. Let's first start off with the design. Design allows for dimensions, sketches, and physical models. Say if you wanted to design a critical component to a rocket, or you wanted to design a table, or you wanted to make a whole car. With CAD, you can do this. You can do every single one of those things. Design is one of the critical components of CAD. It's in the name. Another use for CAD is visualization and simulation. These two go hand in hand. Visualization allows a company to see a part or assembly and how it looks in a three-dimensional realm. It also shows the aesthetic approach to engineering. This also allows the viewer to use something that will make and determine what needs to be edited, or what needs to stay the same, or what can be fixed in the model. So simulation. Simulation, as people refer to as, is a necessity and maybe and sometimes critical. This shows the design if it'll actually work or it needs fixing. In an article by SolidWorks, it states, motion simulation provides complete quantitative information about the kinematics, including position, velocity, acceleration, and the dynamics, including joint reactions, internal forces, and power requirements of all components of a moving function and mechanism. This shows simulation is very useful in the engineering process. Another useful aspect to manufacturing is CAD. CAD and manufacturing also go hand in hand. Many of you may not or may not know what manufacturing actually is. Manufacturing is simply the process that parts are built using tooling and machines. CAD, in many aspects, serves as a simplifier. It makes it easier for those who use it in the engineering realm. CAD in manufacturing is called CAM, or computer-aided manufacturing. The mix of CAD and CAM provide crucial aspects to manufacturing engineers and even mechanical engineers when building things. This allows for the manufacturing engineers to build new things or know if their model will work or not. So CAD and CAM either rule out or suggest new manufacturing processes, knowing the geometries and tolerances needed to be fulfilled. Speaking of fulfillment, let's now discuss the future. So, now that you guys all can realize it, I'm really into CAD. So now that you know what CAD is, or what I've explained it to be, or many explanations that I attempted to provide, there must be more, right? There is. Like any futurist, I like to visualize what there is to offer in CAD. Maybe VR, AR, for example, virtual reality CAD, where you can see the model in a 3D realm using VR gear. Or AR, where you don't need all that gear, but you can still see your model and still see what needs to be fixed. Technology can help the procedure of best design in CAD without zero human errors. This is called generative design. Autodesk explains it by saying, Generative design is a design explanation process that designers or engineers input design goals into the main generative design software, along with parameters such as performance or special requirements, materials, manufacturing methods, and cost constraints. The software explores all the possible permutations of a solution, quickly generating all design requirements and alternatives. It tests and learns from each iteration of what it makes and decides what is the best model. As you can see, the future of CAD, beginning and involved with the generative design and solutions it makes, is promising. As I discussed, design, visualization, simulation, and manufacture, also along with the future, that was just a brief synopsis of what the future is for CAD. There are many revolutions in designs to come. There are models that you can see and simulate with your own eyes without getting out of your office chair or even standing around the model around your office. It also provides a better way to manufacture. There are so many linking technologies and software related to computer-aided design. I cannot wait to see what comes next. Thank you.